In this video clip, I'm going to talk to you about bearings, and bearings are really closely related to compass directions, so that's where we're going to start. On this side, you can see that we've been asked to fill in the compass directions, so they're the basic ones that we already know, so hopefully you agree that north is at the top, south is at the bottom, east on this side, and west over here. And then there are other ones that we could fill in, like northeast, southeast, southwest and northwest. So they're the standard compass directions. What's really awkward about them though is if you look at that, there's only about 8 different directions. It's not always going to be the case that I'm going to want to pick one of those ways to travel. So we have this other thing called 3-figure bearings, and these are giving us more opportunity for different directions to travel in. Bearings are always measured from the same as north, and they're called 3-figure because there's always 3 kind of digits involved. So north is at the top and it's 0, 0, 0. And bearings are always measured from north in a clockwise direction. Okay, so if we think about what you already know about angles, there's 360 degrees in a full turn. You should know that 90 degrees is a quarter of a turn. 180 is a straight line, and then that makes that 270. And I can add other values in here, so there we go, that's 45, that'll be 135, 225, and this one is 315 degrees. What's really important though about 3-figure bearings is some of the ones I've written there wouldn't get me the marks in the exam. It has to be 045 and 090. Your 3-figure bearings always have to have 3 digits when you write them. Right, so to emphasise that point, I've got a couple of examples of angles that I'm telling you are bearings, and I'm going to try and write down what the bearings are. Remember that bearings are always measured in a clockwise direction from north, so north is up here on this one, and I must write my 3-figure bearing for this one. So it has to have 3 digits, so this one will be 048. And if I show you on the second example, again north straight up, measuring clockwise, and again 3 figures, so this one is 009. Okay, here's some examples of rather more complicated ones, I guess, that you might have to calculate in an exam. So again, we're measuring bearings from north, and again it's measured clockwise, and you can see that the bearing I want this time goes past the dotted line up to this solid line, and I have to do a little bit of a calculation. I know I've got a right angle here, so it's 90 degrees plus 24, which makes 114. And on the second example, again from north, measured clockwise, you can see that that's the angle I'm interested in, that's the bearing, and the bearing itself I'm going to have to work out, and it will be 180 take away 12, because a straight line would be 180, and 180 take away 12 will give me the bit that I want. So I'm left with 168, and that's already got 3 figures, so that will be my answer. Okay, getting slightly more complicated again, and remember that you always have to measure bearings clockwise from north. So there's my north, and the bearing in this case is all the way around there. So in this one, again, another little calculation needs to be done. I'm going 180 to that dotted line and then 110 further than that. So my final answer for this one is 290. And if I show you on the second example, again, always clockwise from north, even though that's the furthest way to turn, to face that direction from north. On this one, I'll have to do another calculation. So I'll have to do 360, and I need to take away 155. It's 360 because 360 degrees is a complete turn, and I don't want to do that last 155 degrees of a complete turn. And if I do that, I'll end up with a bearing of 205 degrees. I've got some more examples here of bearings that you might want to calculate. You might want to have a go at these yourself, so if you want, pause the little video clip, have a little go of them, draw some out. It's definitely worthwhile drawing a sketch, and you should always, on these questions, mark on the bearing that you're interested in finding out. You can see on here that I've marked the bearing as the blue arrow there, so again from north in a clockwise direction. And a little calculation for this one, 360 for a complete turn, but I don't want to go the whole way round, so I would take 23 away from 360 and I would get 337 degrees. And on this second example, again measured from north, again on the clockwise direction, even though it's the furthest way to reach that direction, I'm turning more by going clockwise than if I went the other way, but you just always have to do that with bearings. Again, same calculation, a full turn would be 360, I need to do a subtraction and I get 199 as my answer for this one. And this last one's a little bit more complicated. I'm going to have to do my subtraction, and I just need to know what that angle I'm taking away from 360 is. So it's really important that I notice I've got a right angle there, and that right angle with the 45 is the bit of a complete turn that I'm not going to do. So again, measured from north, and if I mark on, that's the bearing that I'm interested in. And I'm going to do 360, and I need to take away the 90 and the 45, and I'm left with 225 as my bearing. In order to do the more difficult bearings questions, you really have to know about your angles in parallel lines. And by that, what we mean is you need to know the relationship between that angle and that one, this angle here and this angle here, this angle and that one there. If you understand those relationships, you can very easily calculate all the things you need to know about bearings. The set at the top, these angles here, these are called alternate angles. You can always spot alternate angles because they are inside the parallel lines, but they're on either side of that diagonal line. The key fact about alternate angles is that they are equal to each other. The second set of angles, these ones, these are called corresponding. And what I like to think of with these is if I snapped this diagonal line somewhere in the middle there and dragged the top one, I could lie exactly on top of there. So these are corresponding angles, and you should be able to see that they are equal to each other. And the final set of angles are the most important ones, I think, for bearings. Okay, so these are allied angles, and the fact about these is they're not equal. They do add up to 180 degrees. What you've got to notice, this example is a pretty good one actually. This angle here is an acute angle, it's less than 90 degrees, and this one here is much bigger than 90 degrees, so there's no way that they can be equal. They do, however, add up to 180 degrees, and this one angle fact is probably the one we're going to use most when working with bearings. Perhaps the biggest problem some people have with bearings is that they don't realise that it's about alternate, corresponding and allied angles. Even they don't always realise the parallel line situation. It's going to help actually, especially if you're looking at this on an iPad or something similar, or a tablet or a phone. If you just try and turn your page, so turn it just a quarter of the way around, turn it through 90 degrees so that these parallel line arrows are pointing upwards, that may remind you of the sort of picture you've seen when you've done some bearings questions. Here's the sort of thing I was talking about. So now the parallel lines are pointing upwards, and if you've looked at any exam questions, you'll see, I think, a similarity between these and some of the bearings questions you've got. Now again, on these ones we're going to use our allied angle property to find out what the missing angle is. So in this case, I spot that I've got one marked as 56 degrees, and I'm asked to try and find out what A is. These are allied angles because they are on the same side of the line that crosses the parallel lines, and they're both inside the parallel lines as well. So this 56 and whatever A is must add up to make 180. To find A, I do 56 taken away from 180. If you do that, you get 124 degrees. Okay, if you have a look at this second example, still we've got allied angles. I've got my obtuse one here labelled as 108, and this acute one, again, inside the parallel lines on the same side of the diagonal. This one, B, must add together with 108 to make 180. So in the end, that forces B to be 72 degrees. Just notice here that my answer for the size of angle B is 72 degrees. It's not three figures because it's not a bearing. If I was interested in finding a bearing, remember I always have to measure clockwise from north. So 72 degrees is just telling me about the size of the angle of B. Okay, still working up towards bearings. What I'm going to do is I'm going to try and calculate on this example the angle that's marked C. I'll just colour that in for you. It's really important that you realise on this diagram the angle that I want goes all the way around inside there. So that's the angle that I'm interested in. Quite a big angle there. Right, so how would I work that one out? Well, to be honest, I can't really do that very easily directly. So the first thing I do is I try and use the properties I know about parallel lines to figure out this angle. The one I've just marked in red, that is an allied angle with the 120. So the red angle must be 60 degrees. That can help me find out the blue one now, because you can see that the red one I've marked at 60 degrees together with the blue one will make a full turn, a full circle if you like. So that must mean that the blue angle is 300 degrees. Same kind of idea on this second example. So again, the question asks me to find the angle D, and D is all the way around that particular point. So it's a reflex angle, which means it's bigger than 180. That's the angle that I'm interested in doing. If I repeat that same sort of logic, I can use my allied angles to find out that red angle there. And that red angle must add to the 77 to make 180. So that means it has to be 103 degrees. And then I use that and figure out what the blue angle needs to be to make a complete turn. So the blue angle plus 103 must make 360, which means that the blue angle marked D is 257 degrees. Right, so now we're looking at real bearings questions. What's important for you to recognise is the difference perhaps between this and the previous example. You can see on these ones that the parallel lines, they stop. They don't continue beyond the diagonal. But if you wanted to in an exam, if it helped you, you could draw them in, and that would perhaps make it clearer to you that this is about allied angles again. So there we go, they could be in there. What we've got to do is we've got to try and read the question carefully, because it's so important when you're calculating bearings that you're doing it from the correct location. In the question we're told that it's from B, and I always recommend if it's on your exam paper that you colour in that angle that you want. So B is this point over here, and so the angle that I want is this bearing that I'm colouring. Remember, it goes all the way clockwise from north around this particular angle here. Okay, so that one I'm colouring in blue, that is the bearing that I'm being asked for. Again, can't work this out directly, so I'm going to have to use my allied angles to work it out in stages. My first step would be to find out what that angle there is, and hopefully you remember that 118 and the angle I've just marked there, they need to add together to make 180. So that means that particular angle must be 62. And then again, same technique as before, 360 is the full turn all the way around there. So the blue angle plus 62 must make 360. If I do a quick subtraction, that means the blue angle needs to be 298. Now that is a bearing, so I do have to have three figures, but it already has that, so I don't have to worry. On the second example, again, it says from B. So this is the place where I'm going to colour in, and that's the angle that I'm interested in. That's the bearing there, inside there. Right, again, can't do it directly, so I'm going to have to do it in stages. The first stage, as you'll remember, is to work out this allied angle. That must be 114 because they have to add together 66 and 114 to make 180. And then following on from that, I can work out what the angle B is by doing 360, take away 114, and I get 246. Okay, here's another couple of examples to emphasize that point. Really can't stress it enough. You've got to get in the habit of reading the question. Where is the bearing being measured from? This example is measuring it from B, and this means I can draw it clearly on the diagram. Please do get in the habit of drawing the bearing that you want on the diagram because it's so easy to get confused. Right, the next thing then is I need to use my allied angles properties, so I calculate that angle I've marked in red. It's allied with 82, so that means it has to be 98 so that together they add up to 180. Now that I know that that one's 98, I can find out the bearing that I marked in blue because together 98 and the bearing must make my complete turn. So I do 360, take away the 98, and I get 262 degrees, a 3-figure bearing as asked for. Right, this second example, I put this in deliberately to try and make sure that you emphasize the fact that it's where it's from that matters. If you read this example, you should be able to see that it's from A. The bearing that I want for this question is actually measured around the point A. It's going to be from the north line clockwise until I meet that direction of travel. So again, I'll mark it on. That is the bearing that we've been asked for there. There is the north line coming from the point A, and there is A, just marked with that blue dot. Right, so again, this feels like we're working a little bit backwards, but I know that the bearing I want is allied with this angle I've just marked in red. And I can work out the angle in red because with that 315, it must make 360 degrees. That means that has to be 45 degrees. And then again, using the allied angles properties, I can calculate the bearing that I want. And the bearing that I want must add up to, with 45, to 180, which means it's 135 degrees. Again, 3 figures, and I feel confident that this one is correct. Okay, I think it's probably about time I showed you an actual exam question. So this one is taken from the Edexcel Foundation paper. It was done in March 2012. It's actually question 20, and it's a fairly straightforward bearings question, but I want to show you how exactly it'll be done. If you have a look at the first question then, the first part of the question, part A, it says measure the bearing of Q, and the key thing is from P. So the bearing I'm asked for, if I just mark it on there, is that one there, measured clockwise from north around the point P, showing what direction Q is from P. In order to do that, you're going to need to use a protractor, and hopefully the next slide will show you exactly how you should line that up. Right, okay, so here we have it. The protractor is put in place. What's really key is you've lined up a 0 on the protractor with the 0 that should be north line. Remember, north is 0, 0, 0. And you should also remember that we measure using a protractor clockwise around the from north going towards the line that I want. The line that I want for this particular bearing, if I just draw it on the top there, you can see, and it's slightly limited because I'm doing this on an iPad, but basically it should be obvious if you repeated this idea that you're looking for a bearing that's just slightly smaller than 50 degrees because we're measuring around to that point there, starting from the 0. So I think in actual fact the bearing is 0, 4, 8. Okay, in the actual exam they give you a kind of room for manoeuvre, so they'll let you off with 1 or 2 degrees either way from the actual answer. Okay, let's look at part B. Part B is asking you to pinpoint the location of another place. The place in question is called R for rock, I guess, and it's from Q. So we're looking at a bearing measured from this north line, again clockwise. It's got to be 150 degrees, so we will have to figure that out again, probably with our protractor. And this other key information is it's 6 centimeters away, so you're going to have to measure 6 centimeters. Okay, if you see, I've put my protractor in place. Again, I've got 0 pointing straight upwards, and I'll be using the outer scale of my protractor as it counts clockwise around there. Okay, the angle that I wanted was 150, so I've marked that in blue. You can see it around the outside there. And still having that blue angle, my next thing is I needed to use my ruler and measure a distance of 6 centimeters. So this should be pretty straightforward to do. Okay, so I make my mark there, and that is the place R. It's, as you can hopefully see, 6 centimeters from Q, and this blue angle made sure that it was a bearing of 150, and that would be enough to get me both of the marks for that question. I hope that's helped you with bearings. Please feel free to watch this video as many times as possible and just really make sure that you get into the real habits of marking on the exact bearing that you're after, making sure you remember that you need 3 figures for any bearings that you write. It's always measured clockwise from north. Best of luck with all your bearings questions. Thanks for watching this.